Okay, Assalamualaikum warahmatullahi wabarakatuh. Today, I will teach in chapter 2. Okay, uniform flow in open channel. Okay, so in chapter 2, at the end of this chapter, students should be able to understand the concept of uniform flow. Okay, calculate normal flow depth in variable channel section using Chezy and many equation. And lastly, you know how to determine the best hydraulic or effective section of open channel. Okay, so we have covered in topic 1 for the basic equation that you will use. Okay, so open channel flow, there is classification based on time, okay, based on space, uniform and non-uniform flow, classification based on time, steady and unsteady flow. And non-uniform flow, we use the GVF and the RVF, rapidly varied flow. Okay, so we know that uniform flow is considered to be steady only. Okay, since unsteady uniform flow is practically does not exist. Okay, so steady uniform flow is rare in natural stream, only happen in prismatic channel. Okay, so without that, assume that uniform flow for most flow computations, because uniform flow calculation is simple, practical and provide satisfactory solution. Okay, so we look at this is the example, the types of channel. Okay, so the 132-kilometer long All America Canal links California Imperial Valley to the Colorado River. Okay, this new concrete line section, so this is the man-made. Okay, the man-made channel that the concrete line section save million year to liquid earthen for so this is the canal, okay, in US. So this is the view, okay, the view of this canal, okay, like the trapezoidal types. Okay, so they have the geotectiles here, okay, the geomembrane. So this is the man-made. Okay, so this is the concrete channel of Los Angeles River. Okay, this is the concrete channel. Okay, this is also the man-made. Okay, actually this is the natural channel, but to make more aesthetics and more, okay, for beautiful the landscape, so the just concrete they used to, okay, to using the concrete channel. Okay, so this is using the types of the view of cross-sectional view of this channel, okay, like the trapezoidal also. Okay, so and also our Klang River in KL and Selangor. Okay, so this is also actually the Klang River is natural channel. Okay, but when we built the buildings near this river, so they use the concrete channel for the Klang River. So the types of the river is they have the okay, the trapezoidal here. Okay, the trapezoidal and also the rectangular here. So actually this is the types of trapezoidal. Okay, so in uniform flow, the normal depth y naught. Okay, we have learned that y in chapter 1 is also in symbol of y. Okay, well, if in this chapter the y naught is a symbol of normal depth. Okay, so this is normal depth for y naught. Okay, occur when depth of water is the same along the channel. Okay, so this is the, okay, the energy line gradient, water surface here and water slope here. Okay, so normal depth y naught is implies that the water depth, flow area, weighted parameter, velocity and discharge at every section of the channel are constant within a prismatic channel. Okay, so the uniform flow, the energy line, okay, the energy line here, okay, water surface and the channel bottom are parallel. So this is the parallel. and the slope are equal to SF. Okay, energy line gradient is equal to gradient of water surface and equal to the water slope. Here is also equal to the S. Okay, so this is the normal depth, okay, for uniform flow. Okay, so velocity distribution depends on the geometry of the channel and wetted boundary roughness. Okay, actually this is natural channel. Okay, so this is the velocity distribution depends on the geometry of the channel. Okay, and wetted boundary roughness here. Okay, so this is rectangular channel and this is the natural channel. Actually it depend on the geometry and the channel that wetted boundary here. So the highlight of this yellow color. Okay, so this is the wetted boundary roughness. Okay, so this one is the velocity distribution. Okay, this contour line here. Okay, so velocity distribution depends on the geometry channel and wetted boundary roughness. Okay, so this must include the y naught also. Okay, so we using the Chezy and Manning equation. Okay, so the two most common equation we use in the uniform flow computation, we use the Chezy formula. Okay, so the using equation of this Chezy formula is from the velocity is equal to C. C is the coefficient of the Chezy roughness coefficient times by radius, hydraulic radius, power of 1 over 2 and times by S naught here. So this is Chezy roughness coefficient. Okay, Chezy formula. Okay, and the second is using the Manning formula. Okay, so we used to get the velocity is 1 over n. N is the Manning roughness coefficient times by r 2 over 3 and s naught. Okay, just a Chezy formula we use the Chezy coefficient, and for the Manning formula we use the Manning roughness coefficient. Okay, so these types of equations usually given in your test or in your final. Okay, so that's the general uniform flow equation. V is equal to constant. Okay, constant is actually for the roughness C and also the and here. So the roughness coefficient and the Chezy roughness coefficient and Manning roughness. Okay, so difference between Chezy and Manning formula, we just the C is equal to 1 over n r. So this is the difference between Chezy and Manning formula. Okay, because this one. Okay, so factors determining the roughness are surface roughness. Okay, so this is the factor that determine the roughness. So surface roughness, vegetation, okay, channel irregularity, okay, channel alignment, silting and soaring, okay, obstruction, size and shape of channel, stage, discharge, seasonal change, and suspended material and bed load. So all these factors are will determining the roughness. Okay, factors. Okay, so we look at the derivation of Chezy's equation. Okay, the Chezy two assumptions to get the Chezy assumption. So we use the force resisting the flow. Okay, flow per unit area of the channel bed is proportional to the square of the velocity. Okay, this one. Okay, I no need to remember this equation. You must just remember the equation that the previous slide that I show you about the Chezy's and also the Manning. Okay, so this is just for the assumption. Okay, assumption that we get the formula V is equal to C times by R and times by S naught. Okay, that's the real equation that you must use in this calculation. Okay, so this is no need to remember, just this is for the theory. Okay, if in your questions or in your test or in your final ask you give or list some two assumptions for derivation of Chezy's equation. So you can explain this theory. Okay. So and also you can sketch the figure. Okay. Actually, so if they mention you to explain, so you must explain. Okay, explain the theory. Okay. So this is the assumption that we use to how the Chezy's formula is assumed. Okay. So used to get the formula, this formula. Okay, to get this formula. Okay. So actually this one. Okay, because from the using the energy line grading, okay, water surface on also the bottom slope channel. Okay, so we get the assumption for Chezy's. Okay, so this is all the how we get the formula to get this. The lastly that this is the most important thing. Okay, so now to worry to derivation of this formula. Okay, because in your final or in your test just ask you to list down or explain about the two assumption. Okay, no need to derivation. Okay, just you must just understand how this formula is used. Okay, to find the velocity. Okay, to find the velocity using the Chezy's. Okay, actually this formula is to find the velocity using the Chezy's equation. Okay, so this is the velocity. Okay, so look at the activity 2.1. Okay, the example for the rectangular channel. So they use the rectangular channel 2-meter wide, carries water at a depth of 0.5 meter. The channel is laid on a slope of 0.0004. So the Chezy coefficient is 733.6. The Chezy, okay, the Chezy coefficient. Okay, so the compute the discharge of the channel. Okay, to determine the discharge of the channel. That's mean to get the Q. Okay, discharge. Okay, so look, we have the rectangular channel. Okay, so we are using this rectangular channel. Okay, so the Y here and the B here. Okay, B and also the Y. Y is the depth. Okay, the depth of the channel is 0.5. Okay, Y is 0.5. Okay, so the Y is 0.5. So given B is water width is 2 meter. So S0 is 0.0004 and the C coefficient, Chezy coefficient is 73.6. So we use this. So you must use this equation. Okay, equation that you learned at chapter 1. Okay, and the chapter. So you use this formula. Okay, so we get the R. So we use the A, okay, using the rectangular channel. So A is equal to B times Y. So we get the 2 times by 0.5. So we get the 1 here. Okay, 1 for the area. So P is the from the perimeter of this channel. So we get the B plus 2Y. They have Y here and also Y here. Y here. So we get the Y here and also the Y here. So that's why B plus 2Y. So we get the B is 2 meter plus 2 times by 0.5. So we get the 3. Okay. 2 plus 1. So we get the 3 meter. Okay. So R, we use the equation R over P. Okay. So 1 over 3 meter. Okay, so we use the equation that we use the Chezy's channel is QV is CR. Okay, 1 over 2 and S not also 1 over 2. Okay, so we know that Q is equal to AV. Okay, so we just A, and the V is this one. Okay, V is this one. Put to this equation. Okay, that's why you get Q is equal to A times by C, this one. Okay, okay. So you get this. Put all the parameter value here. Put the value here. So we get the Q is 0.850 meter cube per second. Okay, so actually we learn in topic 1 the basic equation that we use A to get the area, to get the P, to get the R. So in this topic 2, so we use the same equation in topic 1 to find and determine the value of velocity and also the Q. Okay, so that's why. So you must understand in topic 1 and also topic 2 because we use the equation in chapter 1 to chapter 2. Okay, so in chapter 1, in chapter 2, we use the same equation because we must get the area from the equation in chapter 1. Okay, and in chapter 2, we find the velocity and also the discharge. Okay, so we look at the next. Okay, example or activity 2.2. So water flows in a triangular. So they give you the triangular here. Okay, so triangular channel with side slope 1 over 5. H 1.5 is horizontal and 1 is for vertical. Okay, so horizontal is 1.5 and the vertical is, so 1 over 5 is horizontal equal to 1 over vertical. Okay, so that's mean, okay, the side slope here is this one, 1 over z. Okay, the vertical is 1. Okay, they mention that the vertical is 1. Okay, this is for the vertical. Okay, and the horizontal is 1.5. So this one 1.5. Okay, that means z is 1.5. Okay, so if the z is not mentioned in the, okay, not given the value of z, but it's mentioned in this text. Okay, so you must read your question properly. Okay, so you can find that the z is 1.5 here. Okay, because 1.5 is for horizontal and the vertical is 1. Okay, so given y is 2 meter, okay, y is 2 meter. Okay, bottom slope is 0.002 and Chezy coefficient is this one. Bottom slope is 0. This one. So the depth of flow is 2 meter. Okay, the depth is y. Find the flow rate, get the flow rate and average velocity. So find the Q and also the B based on Froude number. Okay, so based on Froude number, so you must determine the state of flow. Okay, state of flow, so that means that you use the equation that you learn in topic 1 using the Froude number. Okay, to make sure that you know is that the flow is critical, subcritical or supercritical. Okay, so if use Reynolds number, we know that the state is laminar, turbulent or transitional. Okay, but using the Froude number, we must know that the flow is subcritical, supercritical or critical. Okay, so you use the equation that for triangular, so A is equal to Z times by Y squared. Okay, so Z is 1.5, so Y is 2. So we get the value of A is 6 meter squared. Okay, area of this channel. Okay, so the parameter, so we use the P is equal to 2y. Give the y here. Okay, 2 times by y. Okay, so you get the 7.211 meter. Okay, so R over AP is, you get the 0.832, and D is A over T. Okay, because T is from this top width. Okay, so T here. Okay, so you know the T, A over T, or use the equation, D is equal to A over T, so we get the 1 meter here. So we know that the velocity for Chezy's equation is C times by this one, R times by R power of half, and S naught power of half. So we just use. Okay, so and then you just calculate the value of velocity. Okay, after you get the velocity, you use this equation, Q is equal to AV. You get the Q. Okay, so A, we know that the A is 6 meter squared, and the V is, you get this one, so you can get the Q. Q is O AV, so we get the value of Q. So after we use the Froude number to know the state of flow. Okay, so use the Froude number here and the D here, so we get the supercritical flow. Okay, now that's we use the Chezy's formula. Okay, so this is the Chezy resistance factor. Okay, C. Okay, the factor of C. In activity 2.1 and activity 2.2, the value of C is given. Okay, so in this case, Chezy resistance factor C, if not given, so they give you the formula for find the C using the formula of gangulate cutter. Okay, using the gangulate cutter here. Okay, gangulate cutter here to find the C. Okay, the C coefficients of Chezy coefficient using the formula of gangulate cutter to find the C. Okay, but to get the gangulate cutter of C, so also the coefficient of N cutter coefficient is given. Okay, so to find the Chezy resistor using gangulate cutter, so we use the N of cutter coefficient. N is not a meaning. Okay, so N is for the cutter coefficient, so in this formula. Okay, and also we use the formula of Vezin to get the C. Okay, so don't worry, all this formula is given. Okay, if C is not given in the text, okay, the value of C is not given in the text. If C is given as this formula, so you must find C first and use the Chezy equation to find the Q or V. Okay. Okay, so the value of magnetic roughness N also from this one. Okay, the cutter is also use the range of N here. Okay. So if N is not given, so they must give this table to you use to get the range of N. Okay, so actually N coefficient is also always given in the text. Okay, so look at, so this is magnetic roughness coefficient. Okay, so magnetic roughness coefficient N. Okay, so this is the channel. Okay, magnetic roughness here also the reverse. So this actually the roughness coefficient magnetic is from the difference bed of these types of channel. Okay, so it's difference the vegetation, okay, the line, okay, the bed load. So this is the assumption to determine the roughness. Okay, so this is magnetic roughness coefficient in the, okay, using the not erodible channel. Okay, earth straight uniform. Okay, channel with width and brush. Okay, the vegetation. So the range is here. Okay. So for your calculations in your questions, the n is always used. Okay, always given. Okay, in the text. Okay, if not given the n, so you must refer to this table. Okay, to get the many roughness coefficient. Okay, so don't worry, the value of n is always given in your final or in your test. Okay, so that the table of many roughness. Okay, so actually this is the swale. Okay, the swale, also the channel, but the top of the channel is using the vegetation here. Okay, this in our campus here, UTHM. So if you can look the channel swale here, okay, around between the area of College Kediaman Tun Fatimah and okay, Tun Syed Nasir. So you can look the channel of the swale here. Okay, actually let's use the grass, is called the grass swale. Okay, so the surface cover of the grass swale is use the short grass or tall grass. Okay, if the surface cover of this swale using the short grass, so the roughness of the manning is between 0.03 to 0.035. Okay, if the grass is tall, so between the 0.035 to 0.005. Okay, so this is the value of manning roughness coefficient for grass swale. Actually, our campus is use this grass channel. Okay, around our F cup also use the grass channel. Okay, because there's more okay as the landscape, so because it's covered by the grass. Okay, so proposed value of Bayesian coefficient m. Okay, actually if m also using the Bayesian coefficient to get the c, so the value of m is given. Okay, as to get the m. Okay, so just look at the activity 2.3 using the cutters. Okay, Gangulates cutters formula to get the C. Okay. Calculate the velocity and discharge in trapezoidal channel having a bottom width of B 20 meter, side slope 1 horizontal, 2 vertical. So 1 horizontal and 2 vertical. So this is actually the 2 vertical. Okay, so if 2 vertical here, so this is also 2 and the horizontal is 1. Okay, so we know that 1 over z is also equal to 1 is 2 because 1 is because 1 is horizontal here. Sorry. Okay. Okay, we have 1 horizontal, 2 vertical. Okay, so 1 over z okay, 1 over z, we have 1 over z, this, okay, this slope, bad slope, okay, side slope, okay, sorry, bad slope, side slope here, and we know that the side slope 1 horizontal, okay, and 2 vertical, so the vertical is 2 here, is 1, okay, so 1 over z is equal to 2 over 1, okay, so z is equal to 1 over 2. So z we get 0.5. Okay, so we get the z is 0.5 here. We use the trigonometry calculations. Okay, with z 1 over z 1 over z, but we know that side slope 1 horizontal is 2 vertical, so 1 horizontal at the z here horizontal, and the vertical at 1 is the vertical is 2 here, so you just using the trigonometry, so you get the z is this one. Okay, after you get the z, okay, after you get the z, okay, calculate the area, okay, area of the channel. Okay, so calculate the area of the channel using the trapezoidal here. B times y plus yz y over y squared. You get the 138 meter squared. Okay, so P parameter, weighted parameter here. Okay, using the formula given in table in chapter 1. So you get the 33.42 meter. Okay, you get the parameter, and the R you get the 4.13. Okay, after that you just use the gangulate cutter here. Okay, so this formula is given, okay, in your test 1 and your final. So you just use this one to get the C. Okay, just put all the value to this formula. Okay, put all the value in this formula, so you get the value of C. Okay, so you get the value of C. Okay, after you get the value of C here, okay, so use the Chezy velocity. Okay, use the formula for the Chezy to get the velocity. So you just put the value C that you get from the Chezy gangulated cutter formula, this one. Okay, this C, just put the value here to this equation, so you get the velocity is 11.03 meter per second. So after you get the velocity, you get the discharge. Okay, get the discharge, so you get the discharge value. Okay, so in topics 2, okay, you will use the formula or equation in topic 1 to get value of velocity, to get the value of discharge, to get value of Chezy formula and Manning formula in chapter 2. Okay, so just remember that for your test 1, we will cover topic 1 and topic 2. Okay, so these two topic will use the same formula. Okay, so this also activity 2.4, we use the Bayesian coefficient M. Okay, so activity 2.3, we use the formula of gangulated cutter using to get the C using cutter formula. And this activity 2.4, we use Bayesian formula to get the C coefficient. Okay, so use the same activity question, activity 2.3 question. So find the equivalent Bayesian coefficient M for the question in activity 2.3 and compare the Chezy equation obtained from Carter and Bayesian M. Okay, so assume that for concrete, okay, so we assume that these questions use the channel of concrete, okay, using the concrete, okay, with cutter end, with the roughness of cutter end is 0.015. Okay, it's refer to that table for the roughness. Okay, and Bayesian M is 0.21. Okay, actually, so this value is given, okay, is in your test or in your final, this value will given. Okay, so no need to worry, no need to refer to the table or so on. Okay, just that give you the value of N and also the M. So you use the Bayesian formula here. So you use the Bayesian formula. Okay, so you use the Bayesian formula here. Okay, so use the Bayesian formula here. Okay, put all the value here. So you get the C Bayesian. this one. Okay, this is from basin. You get 78.852. Okay, but for cutter you get okay, but the cutter you get 6.769. Okay, this is from the previous slide that you get from the cutter formula. Okay, so this from basin you get this one. So they have the difference between this one to get the value of C. Okay, actually. Okay, so no need to worry. Actually, in your final or in your test, will ask you to use which formula to get the C. If not mentioned, use the cutter or basin, so the value of C is given. Okay, if not given, you must find from this formula, from this basin formula and also triangulate cutter formula. Okay, so we look at the activity 2.5. The trapezoidal channel is 10 meter wide and has a side slope of 1.5 horizontal to 1 vertical. So the base slope is 0.0003. Okay. The channel is lined with smooth concrete and compute. Okay, determine the mean velocity. Okay, the mean velocity and the depth of flow. Okay. So using the trapezoidal channel, okay. So you just use the equation here to get the area, to get the perimeter and get the R. Okay. So you get and you use the velocity using this meaning. Okay. Actually this is activity using the meaning. Okay, because the N is given. Okay, not Chezy. Okay, if N is given, so you must use the Manning equation to get the velocity and also discharge. Okay, so use the Manning velocity. So you get the velocity from Manning velocity, you get the value of velocity 2.359 meter per second. Okay, so after you get the velocity, you get the discharge. Okay, so that's all you get. So in this topic, so you must use the formula in topic 1 to calculate the value of velocity, to calculate the velocity of Q, and also to find the Chezy coefficient using gangulate cutter and also basin formula. Okay, so let us also use the Manning. Okay, so because use the example 2.5, find the bottom slope. Okay, necessary to carry on this one. Okay, in this activity, the Q is given. Okay, given as this. Okay, 50 meter cube per second. Okay, of the discharge at the depth of 3 meter. Okay, so the given B is 10 meter. Because example 2.5, so Y 3 meter, Z is 1.5, and N also 0.0012. But we carry on 50 meter cube per second. Okay, the Q. So you must use the meaning here. Okay, Q is equal to A. Okay, Q A times by V. Okay, V is AR. So this is V. Okay, actually this is V. Okay, actually this is V. Okay, AR over S1 is the V here. And A. Okay, so you just Manning discharge. So you just put the value of Manning discharge Q is the given as this one Q. So you want to find the N. Okay, discharge to get the find the bottom slope to get the S naught. Okay, bottom slope is the S naught here. Okay, so you just get the S naught is 0.00000712. Okay, Okay, so in this case, okay, in this topic 2, in this case of activity 2.6, so they use the same parameter in example 2, activity 2.5, example 2.5. So, but they give you the value of Q, discharge. Okay, so you use the velocity, remaining velocity to get the velocity, but you use the Q, okay, the Q remaining discharge to find the bottom slope S naught. So you can use these equations to find the S naught. Okay, actually you must read the questions properly. Okay, so you must understand what the questions wants you to find. Okay, so if you know, so you can do your calculation. Okay, so you get the S naught here. Okay, this is also the triangular channel with the angle of 75 degree carries a flow of 1.2. So they have the triangular. Okay, it's the given parameter y 0.80. S naught is bed slope. Okay, S naught bed slope is the S naught 0.009. The angle here, okay, 75 degrees, and Q is 1.2. Okay, so we know that tangent. Okay, use the trigonometry to find the value of Z, because they give you the tangent, the angle here. Okay, give you the angle here, so you find the Z here. Okay, okay, you find the Z here because they give you the angle here, so you get the Z is 0.767. Okay, so we get the value of A, P, and R. Okay, so after that you use the main equation to get the Q. Okay, and get the value of N. Okay, because the Q is given, so you must find the N. Okay, depends on your question. Okay, which parameter that you must determine or calculate. Okay, after you get the N using the main equations, so you find the Chezy equation using Chezy equation. Okay, find the Chezy equation. Okay. Okay, that's all until the part A, until the topic 2. So I stop here. So the next slide I will give you the part B for topic 2. Okay, that's all. Thank you. Assalamualaikum warahmatullahi wabarakatuh. So if you don't understand, so I will explain more in our next class, okay, and next week. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.